Assalamu alaikum. Can you all hear me?
Yeah, وعليكم السلام.
Assalamu alaikum. Can you all see the screen? Okay, so about the questions, yes, I am recording this and I have a Facebook page and I'm also streaming it there. So obviously once this we're done with the class, this it would be uploaded there. So you can all watch it from Facebook as well. So I'll share the link of my page. Like it's already in the group description, so you can see it there as well. So that's where you can access the recordings. And about will I teach the topic from scratch or I'll do past papers? So I'll mostly be doing past papers. Obviously, they're like exam is in just a week, and obviously we have I'm just doing uh, probably an hour long class, so it won't be possible to do topics from scratch. So we'll be doing past papers, and I'll be expecting that you guys revise this whole thing. And in the class, I'll be doing past papers and not just like random past papers. Uh, I'll be doing I've like arranged these past papers in a way, or I've been teaching the subject and stuff. So I kind of do have an idea like what are the type of questions that they ask in exam, or what are the type of questions that if students do them, they'll have a better understanding of the topic, so much so that they'll be easily able to solve other questions as well. Like if the questions are a bit different or the question is related, for example, if you're doing projectile motion today, so if you're done with all these questions and you all can easily solve these, so chances are that in the exam, whatever the question is, if it's about projectile motion, you'll easily be able to solve that. So that would be the idea. But if in some cases I do feel that there is a need, or some students want me to do the theory instead of past paper practice, or the past papers are a bit simple, but the theory is what's like challenging. So I'll like teach the theory instead of doing past papers. So that's how we'll be doing this. And uh, a class today will be like obviously from 10 to 11. So it won't go till 11. I'll probably end it around 10:50 or 10:55 because this is a commitment after that. But from tomorrow, like I just did in my O-level class as well. So I've like increased the time. So we'll be doing starting the class at 10, but we'll be ending it around 11:30. Because even when I was like compiling these past papers, so I thought an hour would be a bit less. Okay, so now to start off with the class, uh, you will have two ways which you can ask me, and I'll appreciate if the class goes as interactive as possible. So like be, I'll also enjoy teaching you guys, and you also can like kind of not get bored at least in the class. So you have two ways how you can ask me questions. One is through chat, and the other would be through your mic. So you can feel free to speak on the mic. It's up to you. And about these, a link for these topicals. So, okay, I'll share the link for these. But the link would just be a link on OneNote. So I just uploaded these on OneNote, and that's where they are. So, like, I just I had some books of past papers, and I select these questions myself. But another way for you guys could be the year number is here, so you could also note this down, and maybe if you want, you can do it yourself as well. Okay, so to start with projectile motion, so this question is not necessarily projectile, but the reason I've included it because some student mistake it to be. Uh, can someone tell me what projectile motion actually is? Like what is projectile motion, like how is it different from normal motion, or why is it this different term that we give? Yes, motion in two dimension, and specifically motion in a projectile. So a projectile is when you like just throw something and it like goes on a path, so that path is known as projectile motion, and that's this why this is known as projectile. Yeah, the movement of a particle in two dimensions that has a trajectory. Yeah, that's a very good definition for it. Okay, so mostly the case with projectile motion is we have an object and we throw it somewhere and it goes like this in this direction. Now there are two things. It has, like someone stated, motion in two dimensions. So obviously it does have a vertical component, which is speed v, and it does have a horizontal component which I can write it as h, and the actual component I'll write it as, let's say, s for speed. So it has a vertical component and a horizontal component. So like just to cover some basics, we assume these are the default assumptions for a question regarding projectile motion unless they've stated otherwise, unless like they've stated otherwise in the question, but like they mostly go with these assumptions. So first assumption is there is no air resistance. uh, yeah, that's the only assumption right now. Okay, so the assumption is there is no air resistance, which means that my velocity, which is in the horizontal direction, does not face any resistance at all. So the velocity always remains the same. And as for my vertical velocity, it experiences an opposing force, which is gravity. So the object is supposed to move upwards because of this projectile. The motion is upwards, but there's this gravity which is acting downwards. So like it kind of decelerates the object and reduces its motion. So velocity decreases. till eventually there comes a point on the projectile where it becomes 0. And after that, so like it was 10 and then it became 0 because acceleration was negative, it was deceleration. And after 0, the object starts moving downwards, which is negative acceleration, negative velocity. So the object beyond, after this point, after this half, starts moving downwards, which is negative velocity. So velocity changes like this, and the horizontal component does not change. But if there is acceleration, like if we deviate from the default assumption, then the horizontal velocity would decrease because of this resistance. So would the vertical velocity decrease because of this resistance. So these were just the basics. I thought I just covered these. And yeah, one more thing, that a normal projectile motion when there is no air resistance is something like this. And the best part about it is it is like symmetrical from like its center. And the center point, this is the point where my velocity equals 0. So this is the point where my not velocity, where the vertical component of my velocity equals 0. These are like some things which you should know. And we have some formulas, equations of motion. So if you could all recall them, or I'll just write them here once, and then I'll just assume you all know this. V equals AT plus U. Another formula would be S equals UT plus 1 over 2 AT square. Can you please question one also? I don't know what that means. Another formula was V square equals 2AS. So by the way, you all can speak on your mic as well. I won't have any issue with this. Yeah, I will
S
solve the
equal
first question. And then there was this
S
another formula. Hmm?
S S is equals to VT minus half AT square.
VT.
Yeah,
Uh, no, not VT minus half AT square. It's UT plus 1 over 2 AT square. And
yeah.
if the acceleration is like in the negative direction, so that's why we write half. That's why we write negative. And as for VT, no, it's not VT. Like obviously it could be VT, depends on how you're defining V. So U right now here is my initial velocity. Initial velocity. And initial velocity is what's supposed to be here. So initial velocity. So if you're using V to write initial velocity, which many people don't, and I'm doubting you do, so in that case you can write V. Otherwise, it's the initial velocity. So U is the better term. Okay, so then there's another equation, but these three are what we'll use. Okay, so coming to the question, a stone is thrown vertically upwards. The variation with time t of the displacement s of the stone is shown in figure 2.1. Is this a typical question of projectile motion? Is this a question of projectile motion?
No.
No. Why? Yeah, it's a bit related, but it's not projectile motion. Because when we talk, yeah, both are kinematics, but it's not projectile motion. The reason is, as sort of I think had written above, or as many other had even written, projectile motion is motion of a particle in 2 dimensions. The thrown is only thrown vertically upward, so its motion is only in the vertical y direction. So that's the reason why it's not a typical projectile motion question. Yeah, one-dimensional motion. Okay, so the part is to describe without calculation the speed of the stone from time t equals 0 till time t equals 3 seconds. This is asking me about the speed. So they're not asking me about the direction. They're just asking me about the velocity, not the velocity, just the speed. And from time t equals 0 till time t equals 3. And a better way to solve this question is look at the marks. Mark of this question is 2 marks. So they're obviously expecting us to write the answer and the answer would contain two key points. So to describe without calculation the speed of the stone from time t equals 0 to time t equals 3 seconds. So like, by the way, just a second, I'll be back. Okay, so sorry. So they're asking me about the speed. So can someone tell me what happens to the speed in the beginning and then what starts to happen? This y-axis is not speed, it's displacement. So like, don't confuse yourself with it. So speed increases. No, speed decreases. This on the y-axis is just the displacement. It's not speed. So yeah, deceleration like is would not be a proper word because we're just talking about speed. We're not talking about velocity. So velocity is related to acceleration, not speed. So when it comes to speed, you just say the magnitude of speed decreases, and that's what does happen. Like in a projectile, what happens is from this point to this point till the point of symmetry. What happens is my speed decreases till eventually it becomes equal to zero. So this is the point till where my speed continuously keeps on decreasing till it becomes equal to zero. And once it is now equal to zero, it start it starts like increasing in the opposite direction. That's what happens to velocity. uh, Speed is decreasing because initially, like, uh, on the left side, speed is decreasing because my velocity, like speed is decreasing because there's acceleration. uh, there's this deceleration. The object was thrown vertically upwards. So if I throw an object vertically upwards, what would happen to its velocity? Its velocity would start to decrease till eventually it becomes equal to zero. So from a non-zero value, it becomes equal to zero. So for example, let's say the velocity was 10 meter per second and it becomes zero. Obviously, if I throw a ball with upwards, so there would be a point till which it goes and the velocity becomes zero, and then it starts moving downwards. So the point where the velocity becomes zero, that point, the speed is also zero. And so obviously the initial part, that's how we know this, because when I threw this, it had a magnitude, let's say around 20 meter per second or 10 meter per second, then it started to decrease until it became equal to zero. So my speed became equal to zero. So is this clear? Yeah, I mean concepts and many other concepts as well. Okay, so speed decreases. Then what happens next is, towards the right, that my speed starts to increase. Because speed is only related to the magnitude. So the speed became zero when the object was at maximum height. After this maximum height, it started moving downwards. Now my velocity would have been negative, but right now we're talking about speed, which is like unrelated to the magnitude. So my magnitude starts to increase. My magnitude was zero, and then it becomes 5, 7, or 11 or 12. Now the sign is not important. Like the velocity could have been negative 15, but negative is not important. We're just concerned with the magnitude, which is speed. So speed from zero, it came to a positive value. So this whole region on the left is my speed decreasing, and the region on my right is my speed increasing. So that's how you answer this question. That would be your two key points for this question, and you'll get your 2 marks. The next part, assume air resistance is negligible and therefore the stone has constant acceleration. And by the way, these three formulas, they're only applicable in the case where acceleration is constant and air resistance is negligible. So that's why they always give us this statement in like every question of projectile motion. Yeah, I'll get back to it. To your question, Maya. So they always like write this always. The reason is because DA. If you have a question, then feel free to ask. So they always cite this statement. The reason they do so is to tell us that you can use these equations, because these equations can only be used when a distance is negligible and there is constant acceleration. Yeah, draw a tangent. Drawing a tangent is also an option. Drawing a tangent. Yeah, you're right. Drawing a tangent could also tell me about this. Okay, it is related, but it's like the opposite of the gradient. So if you draw gradient on this side, it would give you a positive value, whereas like it would tell you as if the speed is increasing, the gradient is positive. No, the gradient is not positive. It's like in the opposite direction.
There
Like
is a
obviously no.
speed 0 at 2.5 seconds, like when it reaches the horizontal line.
2.5 seconds is no, the speed is not zero. Okay, so some students talked about speed, so I'll be doing that, and obviously I'll assume that all of you have math. Some students do have biology and chemistry, so I don't know about them, but those who have math, I'll just tell what happens. So the gradient on this would be equal to the velocity. Gradient of a speed time graph, delta s over delta t, is equal to the velocity. So drawing a gradient would tell me the velocity. Now what I do is I need to find the velocity. So now someone just asked me the speed at this point, 2.5. If I draw a gradient, if I draw a tangent here, the tangent would not be zero. The value of the tangent would not be zero. Therefore, there is a speed, and the speed is negative. And if I draw a tangent over here, it's a horizontal line. Horizontal lines have a gradient which is equal to zero, so the speed would have been equal to zero. So you just draw these lines and you see what happens. A steeper line means that the gradient is more, and a less steeper line means that the gradient is less. So maybe whenever there are questions like these, either you just do it like conceptually understand this whole thing, or there's another way. Always draw two lines, two gradients. Whenever a question like this comes, draw two lines. This is line one, and then I draw another line. This is line two. Which one is steeper? The line in pink or the line in blue? The line in blue. So the blue has a greater magnitude and pink has a lesser magnitude. So blue represents the velocity which is greater than the velocity in pink. So obviously this is only the case. This can only be possible when my velocity would be decreasing. Yeah. And then I draw two lines again here, pink, and then I draw blue and pink again. So obviously this time it's not too clear in this diagram, but if you draw it properly, blue would have been less steep and pink would have been steeper. So this time my obviously my velocity became less negative, but the value, the magnitude of my gradient increased. So that's how I know, like that's the reason I can say the speed starts to increase. So that's another way you can do these, all these type of questions. This is a very easy way. Write the answer for 2A on the paper. Okay, so I'll just tell them that till time equals 1.25 seconds, 1.25 seconds, speed decreases. Or then we write that speed increases after 1.25 seconds. Okay, so that's how you write this. And always you remember, depending on the mark of questions, you need to write like key points accordingly. So that's how they mark you. Okay, so let's move on. We've like talked too much on this part. Assume a distance is negligible. Calculate for the stone the speed at time, the speed at 3 seconds. So the speed at 3 seconds, I need to find it. 3 seconds is a point which is here, right? This point. 3 seconds is this point, speed here. Now I could have done this by drawing a gradient. I didn't get what you mean by vector nature. I don't get that point. We could have used area, but area wouldn't tell us anything because uh, area of acceleration time graph tells us the velocity and area of the velocity time graph tells us the displacement. So we have a displacement time graph. Area of this does not tell us anything. Its gradient could tell me the velocity or the speed, but the problem is I don't know what's on the y-axis. So they've not labeled the y-axis. Always use this, Musa, always use this vector nature in projectile motion. Always use it. Like you always need to keep in mind what's negative and what's uh, positive and what's negative. But you could reverse this as well. Like you could sometimes say that uh, or you could say sometimes say that down is negative, downwards is negative, and you could sometimes say that downwards is positive, depending on your convenience. But most of the time in projectile motion questions, we assume that acceleration is positive. Like in this type of questions, uh, we say that acceleration is positive. So acceleration positive meaning that downward direction is positive. So it's up to you. Like just keep a notation for yourself and just do questions according to that way. Don't change, keep changing it. Like just decide for yourself that I will always consider downwards to be positive and then just do accordingly. Okay, so the question, the speed at time, the speed at 3 seconds. So I cannot do this. I cannot. By the way, this question is one of like a very challenging question and a very important question. If you can do this, you can probably do most of the kinematic questions. And similarly, you can like projectile motion questions also become very easy for everyone. Okay, so speed at time, 3 seconds. Now I can't do it by the gradient because I don't know anything. But one thing I know, do I know the acceleration? Important point. In questions of projectile motion or whenever they're talking about objects on Earth, most of the time they won't tell you the acceleration. But they're not telling me does not mean I don't know the acceleration. If it's on the Earth, if it's on the surface of the Earth, just assume acceleration is 9.81. Positive or negative depending on your notation. Like it depends on you. Or like just decide a notation for yourself. Right now, I'll go with acceleration being positive. Acceleration being positive means that my downward direction is positive. The acceleration is downwards, right? So if I'm taking downward direction as positive, my acceleration 9.81 will be positive. No, speed is not related to acceleration. Speed is something very different from acceleration. Velocity is related to acceleration. So speed would have increased either way. Even if acceleration was upwards, it would have been the same. Coming downwards does not matter since so acceleration was downwards was negative. So acceleration was negative or velocity was negative. So I by the way, not even negative. They didn't tell me anything about it, so I can't say for sure. And sort of since it's coming downwards, it should be positive. I don't know what you mean by it. Like you're assuming downward is positive. That's the reason why you're saying this. So if you assume downward is negative, it should have been negative. So it depends on your notation. Downward does not mean positive. Okay, so finally, to do the question, the speed at 3 seconds. Now I know the acceleration. What are the values that I know in this question? Uh, I need to find v, the speed v. The variables which I could have are u, the initial velocity, t, which could be the time, the acceleration, and the distance. I don't know the distance. like the y-axis is not labeled. So I cross this out. Now I need to know these other three values. So how do I find them? Acceleration I know is equal to 10 meter per second. Now u and t, I need to find values of u and t in such a way that I could find my speed. Now there are multiple ways to do this. I'll just be doing this in one of those ways. I take this point, I just ignore the graph on the left. Yeah, I can take that's the way I'll be going with. I'll assume that all the left side of this, the left side to this purple line, I'm just ignoring it. So initially my velocity was zero. So my velocity was zero. So I know that my initial velocity would be equal to zero. And time, the time taken from in this region, from going from 1.25 seconds till 3 seconds. So time would be equal to 1.75 seconds. So that depends on your notation, how you're doing things. So like you could choose to do it differently, and that would like very well work out for you. It depends. I don't know, Hassan, how you got to this 9.81 times 3. Like it's acceleration times t square. So okay, so I'll talk about these possibilities, and this is a bit important. So one of the ways is I do it like this, and right now I use the formula that v equals u plus at. I use this formula, u is equal to 0 plus a acceleration, which is equal to 9.81 times t, which is equal to 1.75 seconds. So I do this and I find the answer. Can someone tell me what the answer would be? 17.16 meter per second. Another way, which yeah, I'll come to that part. Another way to solve this, another possibility was I do not ignore this whole part. So right now, my starting point would have been the point where velocity is equal to zero. So, sorry, not my velocity, uh, just this point. The problem is if you knew the velocity at this point, Hassan, if I knew the velocity at the starting point, then I would have taken time 3. So the idea is that the time you take is from the region is of the region which you're considering. So the way I did this, I ignored everything to the left. So since I ignored everything to the left, so the initial 1.25 seconds were ignored by me. My observation started when the velocity was zero. So that's why I did this. I'll talk about the other possibility later on. Uh, Okay, so the next part, distance traveled from time t equals 0 till time t equals 3 seconds. So we just need to find the distance traveled from time t equals 0 till time t equals 3 seconds. Therefore, yeah, I did use the equation rather than the tangent. The reason I did that was I couldn't have used the tangent because for the tangent I should have known the y-axis was not labeled. They just written s. I don't know if one block is equal to 10 meter per second, 20 meter per second, 100 meter per second. I have nothing. So when I take the gradient, I write delta y over delta x. I can't write anything in x, so I can't use the gradient. So therefore, I go for the formulas. So the next part, the distance traveled from time t equals 0 till time t equals 3 seconds. Now I need to find the distance. And now the keyword here is distance, not displacement. There's a difference. If for both sections, no, we can't count boxes in this question. Uh, Boxes basically refer to area under curve. So area under curve equals speed equals displacement on a velocity time graph. Had they given me a velocity time graph, that then we would have done it. We would have counted the boxes. We will use the formula and split it. So y is u 0. U is 0 because I'm my observation of the graph is starting from the point where u is 0. If you could see, I've drawn a purple line, and that's like the region I'm considering. Okay, so the next part, which was, will we use formula and split it? Yes, we will use the formula and split it because they're talking about distance. Now the thing is, there's a difference between displacement and distance. So if I went out from my house and I started moving, and I moved this whole, I went to McDonald's, had some ice cream, and I went back and I came back. So when I came back, my displacement would have been zero, but my distance was there. I did travel a distance throughout my journey, but obviously the displacement was zero. So there's this difference. When you like move in a direction and you move back, the displacement cancels, like the displacement becomes zero, but displacement will be there. T is 1.75 because I'm only considering the graph which is on my right. I'm ignoring the region where velocity was before. This whole part was ignored by me. So this, the time was also ignored, the initial 1.25 seconds and everything. Okay, so the distance traveled from just a second. We're just not considering the graph for our own convenience. Like some students were asking, why did we ignore the graph on the left? We ignored it because of our own convenience. Like we needed values. I needed these four values to be able to solve this. I needed to use these values and put it in this equation and be able to find something. So if I started from the beginning, I don't know the velocity at the initial point. I don't know it. So if I don't know the velocity, I can't use the formula. No, how can you assume initial velocity is zero? Like if it's before the ball was thrown, then that's not equal time equals zero. At time equals zero, ball was released with some given velocity. So you can't do that. And if you even try doing it, you'll get zeros in your answer. So so I hope this is clear. So the distance traveled from time t equals zero. Distance traveled from time t equals zero till time t equals 3 seconds. And the one with Oppo A53. I've like answered this multiple times, so maybe you can uh, watch the recording and see it for yourself again. Why did we ignore this? Okay, so the distance traveled from time t equals zero till time t equals 3 seconds. So we've now already divided the graph in two regions: the one on this region and the one on the right region. The one on left and the one on right. So the one on left, we find its area or the distance traveled by what could be for the formulas we use. We have a formula for this. Uh, we know a few more things. I know that this whole region, uh, this whole region is the same as this region. All these velocities are the same. These displacements are the same. The displacement traveled in this and on the left, both are the same. Now, what I need to find is this displacement. Is there any way I can find this displacement? I'm just like cleaning this graph so that things could be easier for us now. Is there any way I can find this displacement, the value of this displacement? Is there any way I can do this? S equal dt, but the problem is there's some acceleration involved. So no, I can't just do it as you're saying. VT1 equation, I didn't get you. Okay, so yeah, there are two formulas which I can use, either this one or either this one. But the problem is, for both of these formulas, I'm supposed to know what the initial velocity and the final velocity. I can now use this, like do this in multiple ways. I can do this
Sir,
in multiple.
can we use
Can
the
you?
formula S is equals to minus no V is S is equals to V minus half at square.
S equals.
S is equals to V minus half 80 square.
That's not even a formula. Like
No,
S
it's
equals.
a derived. It's a derived formula.
S equals. You're saying me S equals
V
plus.
minus V minus half 80 square.
Uh, I'm not aware of any such formula. Half 80 square. There's no formula like this.
This was written in my notes, which I have been given.
This is the formula.
Yeah, there were two formulas that I have been given.
Okay, maybe that could have been a formula, but I can't recall any such formula like at the moment. Okay. So now what I do is, yes, I use this same formula. I use this formula where S equals ut plus 1 over 2 at square. I've just ignored the whole graph on the left. Now what I do is I've ignored this, so my u eventually becomes equal to 0. So I just ignore this u from this point onwards. Now, yeah, Vt. So I know about Vt. So I'm not, he was saying V minus half 80 square. Half is
Yeah,
for because of the
I
delta.
just recall. It's VT, yeah.
Yeah, Vt. So that's the exact same formula which I've written here. No? They're the same formulas. Okay, so I have this formula. So S equals 0 plus 1 over 2 at square. Now, depending on what I use as my time, I'll get the answer. Okay, so if I want to find this displacement, this whole displacement, I use this time, which is this is 1.25 seconds, and this next point is 2.5 seconds. So this whole region, this time in between these two points is again 1.25 seconds. So I use this and I put it in the formula, and I get 0 plus 1 over 2 times acceleration, which is 9.81 times t square. T square, which is 1.25 square. Can someone tell me the answer? Okay, so it's 7.66. So 7.66 is this displacement, 7.66. And now, if I need to find this displacement, how can I do it? Now I change the whole time. Right now, my reference point was this. I found this acceleration, 7.66. So I'm now ignoring this. I'm now considering this whole region. So this point is 1.25 and the next point is 3.0. So it's again 1. No, we can't take 3 seconds now. Yeah, yes, you can take 3 seconds and you get the same answer. Yes, we can do it in both ways. So you can use 3 seconds, you get the same answer, or you can use 1.75, you'll get the same answer because the displacement would have been the same. Okay, so when I use this formula, when I use it this way, S equals 0 plus 1 over 2 times acceleration, which is 9.81, and I use this new time, which is 1.75 whole square. What do I get? Can someone tell me the answer? U is 0 because I'm assuming I'm starting from this point. I'm ignoring the left, the region on the left. 15.02. Great. Now this 15.02 When I just used this formula, it told me about the 7.66. Now, when I use this whole formula with time 1.75 seconds, it tells me 15.02. This is what it tells me, 15.02. Now I just add these up, my total displacement. So I went 7.66 seconds upwards, and then I went 15.02 seconds downwards. So if I add these up, what do I get? 15.02 plus 7.66. What do I get? 22.68. Because I'm just assuming the initial velocity to be zero, because I'm still starting from this point, which I have like this vertical line. I'm my starting point is this point. What we can do in projectile motion is your formula always the formulas always give us the correct answer. Yes, we can. I'll get back to it, Hassan. Uh, so what we can do in projectile motion is the formulas always give us the correct answer. So we choose the references according to a convenience. So you could do it in different ways. So some of students were asking me on direct messages that can we use 3 seconds? Yes, we can use 3 seconds. But if I use 3 seconds, what's the formula? The formula is displacement equals. So that would tell me the displacement. So it would tell me if I use 3 seconds, it would tell me the displacement that the ball travels from time t equals 0 till time t equals 3 seconds. The total displacement during this period. That's what it would tell me. And the total displacement would have just been equal to this part. So if you add this thing, can someone tell me the answer by plugging 3 square instead of 1.75 square? No, just put 3 square. Uh, is that what you're getting? Okay, right. Sorry, apologies. The reason we weren't doing it because we don't know the initial velocity. And right now, when we take equals 3, when we t time equals 3, the thing is that we now ignored this part. And now our frame includes this part to this part. So our initial velocity is supposed to be the initial velocity over here and a time t1 over here. So now this u couldn't have been 0. So for this, you need to find the initial velocity. So you can use 3, but then it's no longer 0. It's u, and you need to find u through this formula. So that's a very lengthier method. And but if you do it, you'll get the correct answer. You'll get this. You'll get this displacement, which would be something around, I think, again 7.4 or 7.3. So 7.3 plus 7.66 plus 7.66, you'll again get 22.68. So you'll get the same answer. The next part is the displacement from time t equals 0 at time t equals 3 seconds. So obviously, if you use 3, if you so now this part could be done by what many were suggesting. We just take the value 3 and we find u. That's also a possibility. But another way how we could do this, but first I'll clean the graph. So another way how we could do this, we know these values. We know this region is 7.66 and we know this whole region is 15.02. So can I find this region in green by subtracting 7.66 from 15.02? Can someone tell me the answer? Can someone tell me the answer? 15.02 minus 7.66. 7.36. 7.36. 7.36 would have been my displacement. 7.36. And then they're asking me about the direction. So obviously it's downwards. So downwards is what I write. And now when I'm telling the direction separately, I don't need to use signs. So 7.36 would have been my answer. I hope like this is clear to everyone. Okay, so the next part is draw the variation with time t of the velocity v of the stone from time t equals 0 till time t equals 3 seconds. So from time t equals 0 till time t equals 3 seconds, I need to draw the velocity. Initially, I know how the speed varies. I know that my speed, if I talk about the speed graph, I know that speed, I'm just drawing the speed graph right now. I know speed has an initial value and it started to decrease. It's a straight line indicating that the acceleration, the gradient is constant. The gradient of a velocity time graph is acceleration. So I'll get a line something like this. And speed was then increasing, but velocity has the direction also matters. So if I talk about this graph, my object moved upwards, its velocity started to decrease till it eventually became zero. And after it was zero, the object started accelerating downwards, like the velocity started to increase in the negative direction. So I keep carrying on this line like this. This is how my line goes. So this is all you need to do in this question. The reason why it's a straight line and not a curved line is because the gradient of this line represents acceleration, and they've told me in the first part that acceleration is constant. So that's why we do it like this. I don't need to start the graph with a value. Like they've not labeled the y-axis, so I can just do it as I wish. Okay, so uh, I need to be somewhere, so I'll be ending the class today. And as I told you, so from tomorrow we'll be having extended classes, which will go on till I guess 11:30. And we were supposed to do some questions of projectile motion, but we didn't. So I'll probably try to do some questions or some more questions as well. So like just so you guys get an idea of it. However, there's some questions which I would want you guys to do, like try doing it yourselves. So I'll share the question numbers of these questions. So these are not projectile motion, these three questions. These are kinematics, normal kinematics without projectile motion. So you could just do it, these questions there, and like maybe try solving this. So we can do it accordingly. Uh, Abdullah asked if the class is being recorded. Yes, I'm recording the class, and I also have a Facebook page where I'm streaming the classes. So I'll share the link is the link of the page is also there on the WhatsApp groups, like what's it called, description. So you can see it there. And my apologies, I won't be able to do the class earlier because I have O-level classes which I start at 8:30, which will go until 10, and then 10 onwards I'll do AS classes. So that's the schedule. Okay, so if you guys have any questions regarding this class, you can like feel free to ask it in the group. And as some people sometimes do feel shy, so you can ask me on my number as well. I'm basically the admin on the in the group, so you can ask me the questions, or you could ask in the group if you want others to help, or if there are any questions regarding what we studied today, you can ask them. If there are any questions regarding what you are studying for your AS physics, like something which you've not done in class, so feel free to ask them as well. It'll depend. So I can't like guarantee anything, but it'll depend how long I can take the class. But we'll start at 10 and probably we'll end it at 11:30. Maybe we'll extend it to 2 hours, or depending on like how are we able to progress. Okay, so have a nice day. Uh, we will do moments tomorrow. Yeah, forces and TOEIC, I think. I don't remember what the schedule was, but whatever it's there, that's what we'll do. But before that, we'll do some questions of projectile motion. Okay, so have a nice day. Assalamu alaikum.